Good morning, guys. Good morning. Good morning. Can we start the class? Yeah, we'll start. So yesterday, hi guys. So yesterday we have seen the PYQs, that is NEET PYQs for kinematic. Yes or no? Like previous day, like day before yesterday, we have seen for the first unit, that is physical dimension and units. No, now we are going to see the PYQs of laws of motion. Right? Let us start the class. Yes. So most repeated NEET previous year questionnaires. Right. So let us start. So we have stopped up to the question. This was the last question we have seen, that is a ship is moving westward, yes, with a speed of 10 km per hour, and a ship B is 10 km south of A is moving northward with the speed of 10 km per hour. This was the last question, right? Now the next question, that is in laws of motion, like kinematic has been completed and some questions we will see in laws of motion now. The first question of today's class: 3 blocks with masses m, 2m and 3m are connected by strings. So there are 3 masses they have said. One is m, one is 2m, let me change the color. One is m, one is 2m, one is 3m. These are connected with strings, they said, as shown in the given figure. After an upward force, like a force is applied towards up on a block m. So on a block m, a force has been applied, that is F. The masses move upward at a constant speed v. Okay, they said velocity is constant. Okay, now what is the net force on a block of mass 2m? They are asking what is the force acting on a block 2m. G is the acceleration due to gravity. Right. Now what are the things is given here? Let me first expand this. Okay, now this is force F, right, for mass m. One more thing is acting, that is tension. No, tension, that is towards down, that is away from the body, right, for mass m. Similarly, is it visible, right? Okay, let me change here the color. So this is my mass m, force F, and this is my tension T. Now similarly for mass 2m, this is my tension, and here the string is changed, right? So what should I take? T1. Then for mass 3m, this is my T1, tension T1, right? These are the forces. Now what they are saying, it is moving upward with a constant velocity, that is v is equals to constant. So if I want to write these equations, no, it is moving upward, so I can write F minus T is equals to ma. Then T minus T1 is equals to 2ma. Then T1 is equals to 3m into a, like mass into acceleration, the force. Okay, why we are doing these things? No, to solve the equation, but a simple trick a student will not see. They said it is a constant speed Constant speed. Constant speed in the sense acceleration will be 0, right? Acceleration will be 0. Then force F is equals to ma, right? A is 0, then force will be there. It will be 0. It's a constant force only they are applying. So answer will be 0. That's it. Answer is 0 only, right? So if they have not mentioned what is the force there, right? What is the force, like what is the velocity? It's not constant. Then I can find what is the acceleration. It's moving with constant speed only. That's why acceleration is 0. So acceleration is 0 because it is constant velocity. Muhammad, I'll repeat it. See here, the given question having 3 masses, like block of 3 masses, one is m, 2m, 3m, are connected in a string. These are the strings, right? They are connected in a strings like this. Okay. Now, an upward force F is applied on a mass m. Mass m, it has been applied. It's moving upward with a constant velocity. This is the important point you need to note down. This is a constant velocity. What is the net force on a block of mass 2m? They are asking. Mass 2m, they are asking. G is the acceleration due to gravity. So no need to consider as of now this. Okay, see the diagram. If I take the diagram, if I want to draw the free body diagram, no, this is how I will draw. Force is applied due to, like, string is there here. String is there, no, it is tension. Tension is acting. Tension will be away from the body, right? So it is arrow mark, it is towards down. So this is T I have taken. Similarly, if I consider this mass 2m, no, tension is acting away from the body, that is upward. But here this is string number 1, this is string 2 I will consider. So here T1 will be there, no, like string has been changed, then tension will be changed. Important thing, string changes, tension also changes, tension changes. Okay, so T1. So for 3m it is T1, right? So it is moving upward, no? So I can write the equation. F minus T is equals to mass into the acceleration. Then T minus T1 is equals to 2ma. T1 is equals to 3ma. I can substitute this, but one thing is given, that is constant speed, right? So velocity will be constant, acceleration will be 0. So force will be 0, right, in that block. So it's moving at constant speed. So understood, Muhammad? Jonas? Okay, we'll go for the next question. Right, there is the question. So what is the given question here? Okay, the force F acting on a particle of mass m is indicated by the force time graph shown below. The change in momentum of a particle over the time interval from 0 to 8 seconds says. So impulse I need to find, right? That's it now, like force and time graph is given. So what should I do when graph is given? Find the area of the graph, that's it. So what is the area of the graph in a sense? First take this diagram, diagram number 1, 2, 3. So 3 parts are there. First thing, this one, triangle, no, area of the triangle, area of the triangle I need to find. Then this one, area of the rectangle. First one is area of the triangle, again area of the rectangle, and the third one, yes, third one is area of the, again rectangle, no, rectangle. So I need to find the areas first. What is the area of this? Half into base into height. So area of a rectangle, length into breadth, again here length into breadth. So if I find the area, it's simple, that's it, we got the answer. Like upper part plus down part, I should minus it, that's it. No, that's the impulse force. Time graph has been given, I can find the area of that. Is there any doubt in this question? So calculation you can do it now easily. So this is my 2, base is 2 here, and height is 6. Here base is 2 and the height is, the length is 3. Here the length and breadth is given, that is 2 to 4 and this is 3. So easily I can find it now. So half into base is 2, height is 6. So area of a triangle I will get 6, 2 will get cancelled, right? And then this rectangle and this rectangle, 2 into 3, 6 and this is 12. I will do it here, see, half into base is 2, height is 6 plus, I will change the color in black, okay. Now this is 2 into 3 plus this one is 4 into 3, 2 will get cancelled, 6 plus 2, 6 plus 12, correct no? So 6, 6, 12, 12 plus 12, 24 Newton seconds, because it's force and time, no, this is in Newton and this is in seconds. So Newton seconds is the answer. That's it. Now understood, Muhammad Yunus? Okay, we'll go for the next question. Yeah. So force of 3 Newton acts on a system of 2 blocks. One is mass 2 kg, another one is mass 1 kg as given in the figure. Contact force between the blockers. So I need to find the contact force right here. So here the contact force I need to find. First thing I will write the free body diagram here. For the first one, the mass is 2 kg. So force is applied like this, right? So this is 3 Newton, and then opposing force, that is normal force is there, no, that's a contact force, no. So one will be N here, right, N. Now for the mass 1 kg, that is M2, 1 kg, now the normal will be like this, N, right, N, that's it. Now which side the block is moving? Towards right, no, this side is block is moving, so acceleration will be in this direction, right. Now if I see the diagram, I can write the equation 3 Newton, that is 3 minus normal force is equals to 2 into acceleration A. I will write, acceleration is given, no, acceleration is not given, right, I can write as it A. Now N is equals to 1 into A, that's it, no. Now add these two equations, this is equation number 1 for block A, equation number 2 for block B, right. So N and N will get cancelled, so 3 will be equals to 3A, where A is equals to 1 meter per second square. This is my acceleration, Now they are asking what is the contact force right here. Either I can substitute the value of A in equation number 1 or equation number 2, I will get the normal force. So this 2N will be same. So what should I do? 3 minus N is equals to 2 into 1, where N is equals to 3 minus 2, N is equals to 1 Newton. This is the answer, this is the normal force. So 1 Newton is the answer, I will write here properly. So normal force, okay, normal force is equals to 1 Newton. There is the answer. So, is there any doubt in this question? No, right? We'll go for the next one. Okay. So, look at the question carefully here. Okay, fine. If string is pulled with acceleration of 2 meter per second square, then acceleration of block is. Now, if I notice here, one pulley is fixed. One pulley is okay. One pulley is fixed. One is movable. Right. One is fixed and one is movable. Now, this is the fixed, right? There is the fixed one and there is the movable part. What they said, the string is pulled towards down with acceleration of 2 meter per second square, but in this one a block is there, that is 1 kg block is there. How much acceleration will be there in that block they are asking, right? How much acceleration? See, whenever you are getting these kind of problems, no, remember one thing, if acceleration is there, then these two strings are there, no, it will be double. If force is there, it will be half. Okay, I am pulling with acceleration, it will be get doubled. If force is there, it will get half of that. Question is seen, not seen properly. Wait a minute. Now it's visible. Okay, fine. Right. So think. Listen. Acceleration is given, it will get double. Okay. If force is given, it will get half of that. It will get half of that. So, if acceleration is given, no, acceleration is given. So, what will be the acceleration here? 2 times of that. 2 into 2, that's it. 4 meter per second square. This is the answer, guys. This is the answer. If force is given, no, if force is given, I should consider as F by 2 here, F by 2 here. Totally like, yeah. Wait a minute, let us see. So, F by 2 I should consider. If acceleration is given, A 2A I should consider. This is the difference. Okay, only two difference is there. Acceleration 2A, F is given, F by 2. That's it. Can we go for the next question? Okay. Here is the question. Calculate the maximum acceleration of a moving car so that a body lying on a floor of a car remains stationary. The coefficient of static friction between the body and the floor is 0.15. So, what is given here? First thing, like mu is equals to 0.15 and g is equals to 10 meter per second square has been given. So, what is the friction force? F is equals to mu into n, which is nothing but mu mg, right. So, suppose this is the car, no, this is the car, normal force and the weight of the car. So normal is equals to weight, that is mg. So I substituted in place of n, mg. So this is my frictional force. Now force, that is we know F is equals to force required is equals to mass into acceleration, right. So they are asking what is the maximum acceleration, right. So let me equate this equation number 1 and equation number 2 now. Mu mg is equals to ma, where m and m will get cancelled out. A will be equals to mu mg, right, sorry, mu g, mu into g, where mu is equals to 0.15 and g is 10 meter per second square. So 0.15 into 10, which is nothing but 1.5 meter per second square. This is the acceleration, guys, that's it. So what is the answer? Yes, option C is the given correct answer, 1.5 meter per second square. Can we go for the next question? Yes. So here the diagram, like inclined plane has been given. No, before that I will teach you one thing. I will show you here. So this is the diagram for the inclined plane. I need to resolve it in the components, right. So when block is given, I need to make into the components, like it has been given in angle theta 1 and theta 2. Let me explain here. Suppose this is my inclined plane, which is having theta as the inclination. This is my block, right. This is my block M. Now suppose if I consider this is my block which is lying in the straight surface, so I can say this is my normal and this is my mg, right. So normal will be equals to mg, but in this case normal will not be equals to mg. This one thing you should remember, always normal will not be equals to weight, right. When it coming into the angle, no, it will change. Ayush, hello. Okay, listen the class. So here I need to resolve it into components, right. First thing, this is my normal force N. I will change the color here. This is my weight, right. This is my weight mg. Okay, this is my weight mg. I will give it simple trick here to follow or to find this angles. Draw a diagram like this, which is having 8 parts. Am I correct? No, 8 parts, no? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts. Yes, 8 parts. Now, if I take this is the angle theta, right? If I take this, it will be angle theta. Leave one and draw another theta here. So similarly, I draw theta like this, alternative theta. So 4 thetas will be there. Now this is my mg, right? This is my mg. What will be this one? This is my mg cos theta. Mg cos theta, and this is my mg sin theta. Right. So here if I consider this is my mg cos theta and this is my mg sin theta. So whenever angle is given, you can make this diagram and you can find what is the component of that, mg cos theta or mg sin theta. So similarly, in this given question, so for first one, this is 3 kg block. This is my mg and this is my mg cos theta and this is my mg sin theta. So for block 2, that is 2 kg block, 2 g cos 30 degree, and this is my 2g sin 30. So here it will be 3g cos sin 30, 3g cos 30. So what about the 1 kg here? So 1 kg block will be this mg cos theta, and this is my mg sin theta, that is 1g sin theta. So now I can equate it easily. So if I consider the block as in a straight plane, 3 kg, 2 kg and 1 kg, 3g sin theta, 3g sin theta will be equals to, this is for block 3, should be equals to 2g sin theta, 2g sin theta, that is sin 30. For 2 kg block now, this is my 2g sin theta and this is 1g sin theta. Now they have asked what is the force between the 1 kg and 2 kg block. So the final thing, 1 kg block, this is my 1g sin theta. So these are the equations. So if I write the equations, 3g sin theta minus 2g sin theta should be equals to 3a, like acceleration is a, and then this is equation number 1. What about equation number 2? (2g sin theta minus 1g sin theta will be equals to 2a, this is equation 2, and then 1g sin theta will be equals to a, this equation 3. If I add these 3 equations, either I will get the value of a. If I substitute the value of a in the equation 1, equation 2 or equation 3, I will get the value of the contact force between the 1 kg block. Okay, fine. So you can take the options, this 10 Newton, 25 Newton and 39 Newton and 6 Newton. So you can solve the equation and give answer in the comment boxes, guys. Yes, we'll stop up to this, we'll continue in the next class.